screen. I'll send you a copy of the notes at the end, and there's the recording if you need it. Okay, so it says people enter a line for an escalator at a rate modeled by this function here. And it's a piecewise function. So from 0 to 300, it's this thing. And then from after 300, it's 0. So this is a rate. This is really important. It's a rate, okay? Because when it asks how many people, you integrate the rate potentially, okay? There's also an exiting rate, which I don't know if is applicable to this part of the question, but there's two parts there. That's if that's not clear. Like these are the people getting on, these are the people getting off, and so on. So the okay, so the first question says, how many people enter the line? So that's the people getting on here during the interval here. So the answer is it's the integral of r of t from 0 to 300 dt. Because the this is those that are entering. So more specifically, it's the integral from 0 to 300, 44 t over 100 cubed 1 minus t over 300 to the 7th dt. And this feels like it's a calculator problem. But I'm not sure based on what I'm seeing here, like, were you allowed to use a calculator for this or not?
I believe so.
Okay. The other thing here is that there are 20 people in line at 0. So you would actually add to, I'm sorry, you would actually add to this thing here. This never didn't snip. Great. Let me see if I can grab it. No. Okay. Well, in truth, there's an extra term here. There's the 20 plus this, and there's 20 plus because that's how many are starting out. Okay. So do you have a calculator handy? Do you have a TI?
Probably. I do have
84?
I have an 84.
Okay. If you have one, try integrating this. If you have questions, I can share a calculator on how to do that, but using FNint, which I think is math 9 on your calculator. And I will integrate it also.
Yep, I need to actually grab that real quick.
Okay, sure. Go ahead and grab whatever you need to do to get that.
I'm back.
All right. So could take a little bit. You're going to use X instead of 100. If you've got an 84, I believe it'll actually give you the integral symbol. You just enter the bounds. Make sure you get the exponents in there. How are you doing on that?
Just finished.
Okay.
Just 270.
270. So when you get a number like that, it suggests maybe this could have been done by hand, which I don't know if you wanted to do. But in terms of the AP, I can't remember if you said you're planning on taking it or not. But this is probably a 2-point question where if you forget to add 20, you lose a point. So that's why it's really important to like make sure you get the whole thing. And I don't even think you got to add. I think you just have to show that you would add for that. Anything to follow up on that, or does that feel like it's pretty obvious, clear now how to do it?
That makes sense.
Okay. All right, so part B. It says part B, it says there are always people in line for the escalator. How many people are in line at time t equals 300? So there's people that want to enter and there's people that want to leave. So from 0 to 300, part A, we found that there were 290 people entering, but now we got to figure out how many are leaving. And if you look back up on your problem, it says that they leave at a rate of 0.7 dt from 0 to 300. Okay, and this one you can actually do by hand. It's a 0.7 t antiderivative evaluated at the endpoints. So that's 0.7 times 300, which is 210. So it's 290 minus 210, which equals 80.
Oh, okay.
Now, if you got, let's say you just did part A and you got 270 and you did 270 minus 210, I believe they carry forward your answer. So like you would still get full credit for this, this part. Okay. Part C. Part C is kind of interesting. It says for t greater than 300, when are there no people in line for the escalator? So you know that from 0 to 300, there are 290 people that want to enter. We covered that in the first part A and B. If you scroll back up or look at the piecewise function, you can see that the rate is 0 after 300, which means that no more people get on. Okay, but the leaving, the exiting is always 0.7. That's always its rate. So it's like this. It's kind of like the last one. It's 290 minus the integral 0.7, but this time you go from 0 to some value, which we'll call x for the moment.
Okay.
Okay, so you find your antiderivative, which is it's 0.7, and you evaluate it from 0 to x, and so it becomes 290 minus 0.7x, and this is supposed to equal 0 because these are the people entering minus these are the people leaving. So you solve for x in the usual way, and you get some value. Not sure what that is, but let me grab a calculator myself and tell you. So this one isn't great. It's 414. And I think they're looking for units here in minutes.
Okay.
Is that okay?
Yeah.
Okay. Now part D, part D actually is unrelated to all the other parts. And you see this from time to time on the AP where there's a question that just you could do like if you don't like, and I think the point is here is if you don't know how to do it, part A and B or C, like keep going because you may find that you can do it later on. So here it says, at what time t is the number of people in line a minimum? All right. So the number, this is actually kind of interesting because the number of people in line, it takes into account both those that are entering minus those that are leaving. No, that's not true. No, the number of people in line is just those entering. Okay. So it's just this. Okay. And you probably had a problem. There was probably a question earlier in the course where it gave you a derivative function and you didn't have to take the derivative because they're already giving you the derivative. Like this is the derivative and you just have to set it equal to 0. Okay, because it's the derivative.
Mhm.
And when you give an array, I keep saying this, but it's really important because like if you take a derivative of this, it becomes really messy really fast. But the derivative tells you where there's a min or a max because you're looking for critical points, and critical points occur when the derivative equals 0. So you set t over 100 equal to 0, and then 1 minus t over 300 equal to 0. Which I'm not liking the answer to either of these. This isn't written well because that now I'm leaning towards they want you to take a derivative. Oh boy. Let me graph this thing real quick and see if I can come up with anything that might be more useful before we go any further on this.
Okay.
Because the two critical points are at 0 and 300, which it doesn't help because you're really looking for a critical point in between, which is probably why you have to take the derivative of this, but that's not going to work. To the power of 7. And then we'll go home. And this thing even come back? It does. Yeah, interesting. Okay. Huh. Let me snip in a graph. Let me just shape this graph a little better and wow. All right, let me snip this graph in. So again, this is the derivative. And if you recall, the derivative only has a min or a max. I'm sorry, if this f of x, if this were f of x, we would say right there, there's a max.
Mhm.
Would you agree with that?
Yeah.
Okay, but this is not f of x. This is f prime of x, which means you're looking for crossings. You're looking for where it crosses the x-axis. It goes from positive to negative, that tells you something, or negative to positive, that tells you something. So what I'm trying to say is that like this doesn't, like it's only got the two critical points that we already know about.
Mhm.
And this one has a critical point here. I think it's at 90. I really don't, I couldn't tell you for sure what this question is, how to actually answer this question, because if this were the original function, then you would take a derivative, but it is the derivative, so you don't have to take a derivative. And I guess you just check the endpoints in this case. So you would literally integrate from 0 to 0 r of t dt, and you would add the 20 to it. So whenever the limits are the same, That's 0. So this becomes 20 plus 0. And then you would do 20 plus the integral from 0 to 300 r of t dt, which we already did. That was the 20 plus 270, which is 290. And then the fewest number of people is right here at the beginning at t equals 0.
Okay.
All right, so can we move on to question 2?
Yeah.
All right. So question 2 says, it's another rate problem. The rate at which rainwater flows into a drain pipe is modeled by this function. So again, they're giving you a rate and they don't show it's a derivative, but it is the derivative, okay? The pipe is partially blocked, allowing water to drain out the other end at a rate. So there's kind of like an in minus out thing here.
Mhm.
Depending on, it could also be out minus in. It depends on what they're asking for. But you know, just keep that in mind that this is in, this is out. Okay. And they tell you that initially there's 30 in the pipe. So it says how many cubic feet of rainwater flow into the pipe. So we care about into during the interval from 0 to 8. So that's the integral 0 to 8 big R of t. Okay, dt, but you have to add in the initial value of 30 over here. And so they're really emphasizing this because I guess students forget that. It's that like f of a equals or plus the integral from a to b. Like you're supposed to account for the initial amount, and that's what this is. It's usually at time 0.
Mhm.
So if you've got your calculator handy, go ahead and try with that fn int again and see if you come up with anything reasonable here. Your mode should be in radians, which I don't know how you would know that, but generally it's in radians for these types of problems. So if you get something odd, let me know.
Okay.
And it's so this first part, oh wait here, get that.
Got like 76.57.
Yes, same thing here. So 76.57, 30 plus that. So we got a total of 106.57. We need units, so we'll say cubic feet. Don't forget those units. They'll deduct for something like that on the AP.
Mhm.
Okay. Part B. So it says, let me snip it in, snip this in. Is the amount of water in the pipe increasing or decreasing at time t equals 3? So you know if it's increasing or decreasing based on the sign of the derivative. Okay, so your derivative is this r of t right here. So you literally just substitute t equals 3 in there. So you're just doing r of 3, which is 20 sine 3 squared over 35. Now give me just a moment here. Let me make sure that it's actually per hour. It is. So t is in hours. So it's 20 sine 9 over 35. So you calculate that. And you get 5.1. It would be good to give units. The units are given in the question. It tells you cubic feet per hour. Have you taken a physics class?
I took
Okay,
physics 1.
great. So it's kind of the same thing as that. You gotta have units all the time, and that's what's going on here. You gotta have them. Now, how to figure out whether it's increasing or decreasing? So if if f prime of a is greater than 0, it's increasing. If f prime of b, I'm sorry, a is less than 0, it's decreasing. So because r is the derivative, you can just say r of 3 is greater than 0, which means that it's increasing. You could write a sentence. Go ahead. Sorry.
The one thing I do have a question about is what about the water that's exiting the pipe?
Oh, I'm so sorry. It does say the amount of water. I thought it was asking just about the, okay. So I haven't done, so the total derivative here, you have to subtract d of t. So let's do a total. So total is r of t minus d of t. So we'll still be able to use this number, but we need to figure out whether it's increasing or decreasing. You need to do r of 3 minus d of 3. So we actually do need to find that d of 3. Minus 0.04, 3 cubed, plus 0.04, 3 squared, plus 0.96 times 3. And that's because it's a rate. So actually not surprising, it's 5.4, because the way I was doing it would be marked wrong, because it would be 5.1 minus 5.4, and that's approximately negative 0.3, but more importantly, it's less than 0. So that means it's decreasing. And that means that there's the amount of water in the pipe is going down, which could be good, could be bad. All right, so at what time is the amount of water in the pipe a minimum? So this, again, you need that r of t minus d of t, because that's the total amount of water. And you want to set this equal to 0 to find the critical points, because they're both rates.
Okay.
20 sine t squared over 35 minus 0.04 t cubed plus 0.4 t squared plus 0.96 t. So there's no way to do this by hand. I'm going to graph it again. Hopefully we get something reasonable. So your important thing here is that you go from 0 to 8 on your window, on your X. I know you got to do it on a calculator. So make sure the X min to X max is 0 to 8. The Y min to Y max, that's a little harder. You're looking for, I mean, it depends on what we're trying to do. Let me scale mine, I guess. 0 to 8. Let's go -2 to 10. Does that get it? Yeah, that gets it all. Okay. right, so I'm gonna snip in my graph here. So because it's the derivative, the critical point is where the derivative equals 0. This is the derivative, so this is your critical point. I know it could look like this one and this other one are critical points, but they're not.
Mhm.
Hopefully that's clear. Early in the course they would have discussed that. So the derivative changes sign. It goes from negative in this region to positive. And so if like I would prefer to make a sign chart. Like let's assume you got 3.272 and it goes from negative to positive. That means the original function is decreasing. It's somehow going down and coming back up. That's why it's a min there.
Okay.
Justify your answer, some combination of what we did. You could use the second derivative test. That's always kind of a guaranteed way to like be correct on it. Do you want us to do the second derivative test? Actually, that would be really hard on this one, but we could do it. Because you have to take a derivative of what we just
Derivative.
did of this. Yeah, the d of we'd have to take a derivative of this thing and then evaluate it. Everything okay there?
Yeah, that was my dad. He's watching basketball.
Okay. All right. Yeah. Great. So last question. And this is a kind of a preview of Calculus 2. Are you going to take Calculus BC in high school or are you off to college soon?
I'm a senior, so
Okay, well, let's assume in some world where you actually take Calculus 2, you end up doing more of these right, but do not solve. And they actually, they will in calculus, you generally say set up, but do not solve. And the nice thing is like, that's usually like a little more straightforward because it's just a different thing. So the pipe can hold 50 cubic feet of water before overflowing. Okay. And so we have a problem because like I'm sure eventually there's going to be an issue. So it says for t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow, right? But do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. Okay, so the total amount of water in the pipe is what it started with, which I think was 30, plus the integral from 0 to 8, okay? Oh, so this, okay, so see how the original function is only defined from 0 to 8?
Mhm.
Okay, they're saying like, ignore that. They're like saying like, hey, it's gonna keep going. So from 0 to sometime w, you're gonna integrate the amount in. So the 20 sine t squared over 35 dt. So this represents how much is going in. And then you subtract how much is going out. So the amount that's going out is 0 to w because we don't know how much time, but we know it's greater than 8. And then that's that d of t. Now what I don't know, and I'm going to write it this way just for the moment. Like, I don't know if you can write d of t. So you might want to check on that. I do some AP prep stuff, but I haven't looked at it this year to remember. Like this is r of t. This is d of t. Like, I don't know if you have to actually write out the whole minus 0.04 t cubed plus 0.4 t squared plus 0.96 t. Okay. But this is only part of it. This is how much is in there. We care about when it gets to 50. Okay, so we care when this total is greater than 50. So we'd somehow want to like set up this inequality. Does that okay? Because this is the amount
Yep.
going out. This is the amount you started with.
That makes sense.
Okay. Have you selected a school for college?
No, I'm mostly getting my results back now,
Okay.
so
All right. Okay, so last question here, probably the same here. Boy, okay, grass clippings are placed in a bin where they decompose. So they're giving you variations on the same scenario. Like there's some that goes in, some that goes out. They're just giving you a different context, not a different equation. They say that the amount of grass clippings remaining, so that's taking into account both what's going in and out is this right here. Okay. The first question says average rate of change. Average rate of change is not even a calculus concept. It's a concept you would see in a previous course, but it has a formula, f of b minus f of a over b minus a, except this time you're doing a of 30 minus a of 0 over 30 minus 0. And what I think is kind of interesting is I think you can actually on the AP, and I'm vaguely remembering this, is you can actually leave this as 6.687.931 to the power of 30 minus 6.687 times 0.931 to the power of 0 over 30 minus 0. I think this will give you full credit. Like they don't expect you to calculate it, or maybe it's a small deduction. I don't, quarter point or something, but
that I think goes along with what my teacher said last semester.
okay. Yeah, I wish I knew all these things to tell you, but and we get that number if we need to, but that is the meaning. And it's not a calculus thing. So again, some of those questions are, you know how to do. And don't be overwhelmed by it. Just try to take them piece by piece if you can. Okay, part B says to find the derivative. And oh, I'm sorry, I did not finish this one. You have to give proper units. So the units are the units of y, okay, which in this case is pounds. It's the units of y over the units of x, which is days, pounds per day.
Okay.
All right, find the value a prime. So a of t is 6.687.931 to the power of t. The derivative of this, you treat this kind of like it's an e function. Its derivative is itself, 0.931 to the power of t, times the natural log of the base. So like if it were e, the natural log of e is 1, but in this case, it's natural log of 0.931. And then a prime of 15 means to put 15 in for t. And its units are the same as the average rate of change, because the average rate of change is the slope is the derivative. It's all the same, pounds per day.
Okay.
Now we're going to interpret, and the interpret is it's a sentence that it's kind of a fill in the blank each time. So you would say let's see here, the amount of grass clippings remaining. So this first part is the context.
Mhm.
Is, and then you have to choose here a word. It's either increasing or decreasing. In this case, I know that it's decreasing, but you can get this number. It's going to be, I'm just going to call it negative k. I don't know what it is, but it's going to be negative. And it's a choice here. You either select decreasing or increasing. At So we'll fill in the blank at a rate of, okay. And this is where you insert your number. Okay, but it's always positive here because you wouldn't say that it's decreasing at a negative number. It would just be that K, like whatever that number is that you get.
Mhm.
Okay, rate of, and then here you insert your units, pounds per year or per day.
Okay.
And if you take this class again in college, or if you see another like question where you end up having to do this, like it's always the same. It's always fill in the blank. There's some stats classes that are like that also, where you literally just fill in the blank each time.
Mhm.
Okay, on to question part C. Do you find this interesting, these problems, or are they kind of, not all that exciting?
Well, I don't like math that much usually, so.
Okay, it's fair. I mean, I don't find the problems involving grass clippings very interesting, but maybe there's a topic in in the real world where you can understand how there are rates, things change, ins and outs, and maybe there's something there that's you next time you see it, you'll understand how they're calculating it or coming up with it. But this isn't super interesting. I mean, grass clippings, who cares? We don't even have grass here. All right, for the time t, for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval 0 to 30. So find the time t for which the amount of grass clippings in the bin is equal to the average amount of grass clippings. So the amount of grass clippings is your integral of your rate. Okay, and then the average amount is the 1 over b minus a integral of your rate.
Mhm.
But in this one on the right, it's from the entire interval, whereas the one on the left, you're not sure. Like you go up to where you think it is. So you probably had some definite integrals where you find the average, I guess the average over it. But in terms of like what you do here, it's the integral 0 to t, what is it, 6.687, 0.931 to the power of t, equals 1 over 30 minus 0, integral 0 to 30, 6.687, 0.931 to the power of t dt. So this right here on the right, this is a number, and I'd like you to find that number for me using your calculator.
Okay. I got 2.75.
Yeah, same here. So the following is something you might use in college, but I don't remember if it applies to the AP. But sometimes like you can get so stuck on a problem, you can be like, I have no idea, and I didn't have a DT. But you could say like, you could almost like write a sentence as like, if I knew what this is, which you don't, and I'll call it 3 minus x, I would then solve for x. And what it shows is that like what the next step to do is, even if you don't know this intermediate step here. But you probably do. You probably know the integral of a to the x dx is a to the x over the natural log of a. And this is one of those like known integrals.
Mhm.
So in your problem, like the 6.687 comes out, You treat it kind of like an e, the integral of e to the u or e to the x is e to the x, but then you divide by the natural log of 0.931, and then you evaluate it from 0 to t. Okay. This one, when you evaluate it t, it's obviously it's the same thing, 6.687. And you can actually bring out this, not this bottom here. So it's really 0.931 to the power of t minus 0.931 to the power of 0 equals 2.75. And this is one, this is whatever it is. So you're solving for t at this point.
Mhm.
So let's see here. T equals 2.75 times natural log of 0.931 over 6.687. This is one, this is minus 1, so you would add 1. You would take the natural log of both sides again, and then you would divide by the natural log of 0.931. And I'm sure you can look at those steps later if you really were eager to get through it, but and just full disclosure, like I've worked at places where we don't necessarily do this type of calculation, but we never do this by hand. We always use a computer. We always check it with
Mhm.
multiple approaches to make sure that like it's actually right, because by hand is the best way to make a huge error. And
Yeah.
you sometimes read about them where software is written where they have the wrong sign and things crash instead of, and instead of landing softly, or you lose track of a satellite. I don't know if you follow any stuff like that in the news, but all of that's mostly caused by math or errors in understanding. So right. Is there anything else you would like to look at today?
That's mostly it.
We've got a few minutes left. If you want us to look at anything, we could. Otherwise, we can just end here. It's totally up to you, though.
I don't think I have much without starting something completely different.
All right. Well, if you have time, maybe try these out again. But if you don't, hopefully you got some good value out of today's lesson and some good practice for the AP.
Thank you.
All right. Have a great night. Bye now.
You too.